Started. Good morning, everyone. Thanks so much for joining us today for our session with Timeseer. Um, I'm Leah Munchow, a customer success operations specialist with Swan Black, and presenting today we have Mike Waleska of Swan Black, who will give a brief introduction to our organization and partnerships and services that we offer, and then Adrian Van Horenbeek of Timeseer will jump into the core of the content, looking at the importance of sensor data as the foundation for ESG reporting, operational efficiency, and AI. Before we get started, just a couple of quick housekeeping items. Everyone is muted at this time. If you have any questions during the presentation, you can use either the chat or the Q&A section. And then the session is being recorded, and we'll share that on-demand link with everybody in a follow-up email. So without further ado, I'll kick it over to Mike.
Thank you, Leah. As Leah mentioned, my name is Mike Waleska. I'm an account executive with Swan Black, and we are a global certified solutions partner for Timeseer, essentially helping manufacturers unlock more value from their existing industrial data sets. Whether that's improving process performance, helping plant teams solve problems faster, or making those insights more usable and repeatable across locations. A big part of our work over the years have actually been around analytics. If you look at the slide there, we've been a SEEK partner since 2019. If you're not familiar with SEEK, it's an advanced analytics and decision intelligence platform. And one of the things that we've discovered is that if the data is not trustworthy, everything on top of it becomes harder. Reporting, optimization, and most certainly AI. When you have things like missing values, drifts, spikes, flat lines, the downstream impact can be bigger than most teams realize. It can affect dashboards, KPIs, reporting, and ultimately the decisions people make, which is a reason why, the primary reason we added Timeseer to our portfolio in 2023. And that was to help our customers build a stronger data foundation to support their analytics and reporting. So today's session is really about that connection. Why trusted energy data matters, what goes wrong when it can't be trusted, and how manufacturers can build a more reliable data foundation to support their analytics and decision making. And having said that, I'll go ahead and hand it over to Adrian for the presentation.
Thanks for the introduction, Mike. Let's indeed dive immediately into it. And then, so I'm Adrian, based in Belgium. I'm working for Timeseer. Like Mike explained, we're a software company, especially focused on everything what has to do with sensor data validation and sensor data reliability. We work in different verticals. It goes from utilities, water, energy utilities, other verticals, manufacturing, chemicals, food and beverage, oil and gas, everywhere basically where there is sensor data that needs to be validated and trusted before it's being used in all kinds of data-driven applications as well. And today I will be focusing more, especially on the topic of energy data. Why energy? Because we see with a lot of the customers that we're working with nowadays that energy matters more than ever, especially in the current times. It's really strategic currently and not just a cost center or an expense like it maybe used to be in the past. And why does it matter more? Of course, the context is changing. Energy has become really unpredictable and really strategic because of different things. We all know the geopolitical instability is driving price volatility, for example, which really makes it, energy is no longer a stable utility cost. It's now really a board level concern impacting your margins, the resilience of your company, and also long-term planning and organization, of course. On top of that, demand for electricity is surging faster than the supply can keep up. Think about AI data centers and so on that consume a lot of energy, of course, as well. The second one is really regulation, because energy is really a compliance topic and an audit topic, or becoming it more. There are more and more frameworks being put out there as well towards compliance, corporate sustainability reporting, you need to do IFRS reporting and so on, making really energy and then also, for example, carbon or emission reporting really mandatory, and it should be really auditable, which also means that you actually need to be able to prove the trustworthiness of the data that you are using and that you are reporting as well. That also means that it's directly linked to financial exposure, regulatory risk, corporate accountability, for example, and organizations really must provide traceable, sensor level data that can stand up to the audits they need to adhere to. And then last but not least, of course, the business impact. Compliance risk, like I already mentioned, it leads to audits, to fines, penalties, reputational damage as well. On the operational risk side, unreliable telemetry data or sensor data results in inefficiencies, missed optimization opportunities to reduce energy, potentially downtime as well. And of course, there is a financial risk related to it, as I will show in some of the cases I will be talking about around, for example, incorrect data that drives billing errors, missed savings, etc. So for all of these, that should illustrate the why it is currently important to have really trusted sensor data, because sensor data, energy meters, for example, are the foundation of this new reality, but only, of course, if your data that you are receiving from those devices in the field can be trusted. And that's really where we focus on as a company. This is a bit our vision. What if North isn't really North? So each sensor out there that you're using within your current operations, you can see there's a small compass that should point you into the right direction. But of course, if your compass is off, you're not pointed in the right direction, which leads to suboptimal performance, of course. And that's really where we're looking at. If you look to the industry and specifically towards energy, like mentioned, if you have bad sensor data, it will only make things worse. How to link it to the typical profiles of users we see across our customers where we're working with. Look at sustainability directors, for example. Unreliable energy data creates real risk around corporate sustainability reporting, ESG compliance. For energy managers and plant leaders, it slows down performance improvement initiatives, like initiatives to reduce energy consumption, and then especially more for the digital transformation teams. It of course weakens the foundation for advanced analytics and AI, because the more we use more advanced analytics techniques and AI techniques to optimize energy, for example, the more the saying garbage in, garbage out becomes important, of course, there as well. When you look at where the impact actually hurts typically organizations, that's something that we see across three big buckets or main verticals, if you can call it as such, within our customer base. The first part is really people manually working with sensor data. Think about people that need to report every month towards government, towards CO2 emission reporting, for example, these kind of things. They typically spend a huge amount on manually validating data each month, making sure it's reliable, and then really in a reactive way also starting to correct in the best way possible the data before it's being used towards reports. Another group that we see here is data scientists, for example, because if they want to build advanced analytics algorithms, AI, machine learning applications, of course, they need fit for purpose and good data before they can do this. Second use case is typically more on what we call enterprise use cases. Think about digital twins, for example, to simulate, optimize energy consumption of a production plant, for example, or a process line. In there, the difference is, of course, if you want to optimize production, it needs to be real time or near real time, which makes it different compared to the first bucket. you need other capabilities because you need to be able to, for example, automatically correct and clean data and make sure it's trustworthy before it ends up in the digital twin that you are using. And of course, it's impossible to have a human in the loop when every minute you need to send data to a digital twin that simulates or optimizes certain things as well. And then the last bucket is, of course, correcting data after the fact. It's nice if you need to use it for a report, but of course, the more you can guarantee the reliability at the sensor level, so really at the source where the data is being generated, the better. Because every step in the process chain that follows it will, of course, have the advantages of having that reliable data. So that's also typically where our application is being used to monitor sensor data at scale and really indicate like, okay, are there sensors that need recalibration, for example, that need to be replaced to really ensure data is good as of the source in there. When you look at things that can typically go wrong, and probably you know these things as well if you work with data or sensor data. There are a lot of things that can go wrong in there, and a lot of those things are typically missed or only reactively identified. Think about sensor data going stale, so flatlining. Think about very big outliers and spikes. We often come across those in energy meters, for example, as well. Gaps in the data, broken correlations. If you look to multivariate analysis between certain parameters, impossible jumps, sensors that drift over periods of months, where it's very difficult to see it if you only look to a short time period, for example. But if you look to a long time period, you can actually see those things as well. So yeah, a lot of things that can go wrong in there as well. If you look at I'm sorry. If you look at now we described all the things that can go wrong where it has an impact, of course. The why. Why is it important to start monitoring sensor data from energy? Of course, the next question is how do you make sure north is really north? To make sure that you can trust the data that you're actually using in your reporting, in your optimization initiatives, and all the data-driven applications that make use of it. And that should, of course, lead to validated and trusted data. So that's really the objective. That's also what we enable with our customers. So yeah, verified compliance and audit-ready reporting, the traceability on top of it, real-time operational visibility and efficiency improvements as well. Instead of reactively acting on things, you see that a sensor was broken only 2 months after the fact. We immediately identify those. Financial accuracy for billing, for example, for allocation, cost control. So there are a lot of cases at customers that we do where we monitor the measurements that are actually being used in billing. It can be utilities, it can be energy, but also think about feedstock and so on, what goes into your production. And then last but not least, everybody's talking about AI and advanced analytics. Like mentioned before, garbage in is garbage out with those techniques. So you really need reliable and validated data for making sure that you can actually do AI at scale if you want to optimize energy consumption as well. How do we do it from a Timeseer point of view? We call it AI-driven data validation. I will come back to it because we also use AI to actually validate data and make sure it's trustworthy and fit for purpose. And we call it actually a process that is sensor data validation, where the definition of sensor data validation is, it's a systematic process. So it's something that you do on a continuous basis based on our technology or software, ensuring that the time series data that is coming from instruments, devices, sensors, whatever you have out in the field, actually accurately reflects the underlying physical system. And then also make sure that the data is fit for purpose before it's used in dashboards, in analytics algorithms, in reporting, and wherever you might use it. We often call it fit for purpose because does it need to be perfect? No, but it needs to be fit for purpose for the purpose where you're using it. which typically also depends on, are you using it for a report, for a digital twin, then fit for purpose will have a different meaning as well. How do we enable this? And I will give a short demo of our application later on as well. And then you will see those 3 steps coming back as well. The first one is detection. Of course, you need to detect those issues. Think back on my slide on what can go wrong with sensor data. There's a lot that can go wrong. So in our application, we have more than 150 checks actually. They go from easier things like detecting gaps, connectivity issues, flat lines, to already more advanced things like drifting measurements, for example, to then really AI machine learning based techniques where we monitor, for example, correlations between multivariate relationships and so on as well. So that's really our detection engine within our application. The second one is, of course, if you detect things, you typically also want to validate those to view if actually the data is fit for purpose for its intended use as well. And I will show you in our application, we actually support the validation process with a visual user interface where people, like I mentioned, that typically are manually working with data to generate monthly reports and so on, can actually do the work and then immediately have auditability and traceability of everything that has been done as well. And then, of course, detecting things is nice. Resolving things is better. So within our application, we actually also support the resolution process because not for each application the resolution process will be exactly the same. Like mentioned, if you have to send a report to government, for example, you're probably going to correct faulty data because you cannot go back in time to fix the sensor. But of course, if you proactively monitor things and you see things are going wrong with certain sensor measurements, you're of course going to go out into the field and interact with the sensor over there. It can be calibrating, it can be tuning of the sensor, or fully replacing it when it's broken, for example. Again, to ensure, like mentioned before, that the data is fit for purpose as from the source actually. And this is also the process that we enable within our technology and that we follow through. Why are we called Timeseer.AI? Because for a lot of the things we use AI as well, because there are a lot of things you need to keep in mind when you want to set this up in a scalable and efficient way. The first block is actually in the configuration. So we use a lot of AI techniques to help our users to immediately get to an optimal configuration. We can, for example, automatically detect which type of sensor it is, tune the checks and the validation rules we're doing based on the type of sensors that we have detected, to really guide users in the configuration process. Because if you have thousands of measurements and our biggest customers are monitoring more than 1 million measurements in Timeseer, then you don't want to spend time on manual configuration. You want AI to help you to get it as quickly as possible out of the box up and running. Similar to the detections that we do, you don't want to get an overload in terms of all kinds of false alerts. So our algorithms actually learn from the normal behavior of sensors and then only trigger when deviations from the normal behavior are noticed. Which means that you don't have to do any manual configuration in terms of setting up our algorithms. They basically train themselves based on the data you feed into it. Other things are in there as well, correction algorithms, but I will be showing it in the demo, because often, you have typical profiles in there, daily consumption profiles, weekly profiles, etc., where you want to use more advanced techniques to impute gaps, for example, or to correct certain data. And then especially as well, we call it insights in our application, but these are aggregated summaries to actually point our end users into the right direction to do root cause analysis as well. But I will show you during the demo part as well. So having said that, does this really exist? Yes, it exists. So I'm quickly going to stop sharing my slides, and then I'm quickly going to switch to our application itself. And I will be touching the surface of our application, but then at least you have a bit of a feeling on how it works and how it looks like. So now you should see my screen with Timeseer on the screen. So what you will see is this is actually our user interface of Timeseer. And what you will see is you see Adrian's watch list on the screen. So it's here. What is it actually? It's a personal to-do list. So assume that I'm responsible to do energy reporting every month, for example, or emission reporting. Then I can subscribe in Timeseer to certain streams or sensor data. And when something is wrong with those sensors, I will be notified in my personal to-do list in Timeseer. And that's actually what you see here. So the last time that Timeseer analyzed the data is 53 minutes ago, and we report on the last month of data. And then you see the number of critical issues and the number of at-risk issues that Timeseer has detected. When I'm done looking at it and I see Timeseer has detected new things, then I can go in, and then you will see, like mentioned, we tune the different validation rules and checks that we do. So again, like mentioned, you will see stale data we're detecting gaps, we're detecting connectivity issues, we're detecting big spikes, drifting measurements, for example, outliers in the dynamics of the typical signal that we see. So a lot of things that we can validate and automatically detect, and then automatically notify you as well when we find certain issues. So if you look at it, I'm here looking to energy data. I can open this up in Timeseer, and immediately you will get this summarized view on which of the measurements are having actually the most issues. Do we have incidents? So that's something that Timeseer automatically groups. If we have issues that are happening at the same time, then we will group them, because typically if something happens on 1000 measurements at exactly the same time, you don't want to go through 1000 individual alerts to then after 3 hours find out that they are all related to the same issue and time window. That's something that Timeseer is automatically doing. And then also based on some other pattern recognition techniques and so on, we build, for example, also cyclical behavior, because that might help in trouble shooting as well. If I really want to see what is going on, I can click through on this, and then you will see each of the individual events that are listed by Timeseer. Let me just take the first one. And this is values outside unit range. That's automatically that we look into the metadata of a measurement. So you will see this is an energy measurement in kilowatts expressed. And of course, you see here I have negative values, which is impossible. So that's actually something that I need to review or potentially correct before I start using that in my billing, in my reporting, whatever application you use. In Timeseer, you can follow up then. I can put it under review. I can say broken sensor or whatever the reason is. And then you will see we have the full audit trail as well. So if I change things, which makes it fully auditable and traceable to everything that we do within the application as well, which is especially relevant if you need to do ESG reporting towards government, because it needs to be audit ready as well. You get it all in one application. When I'm going back, I can show a couple of the other examples as well. If you go into stale data, for example, you see this one has 46 days of stale data. I can go in, I can look at an interactive chart. Indeed, it flatlines now, the measurement. If I move it more to the left side, then you will see certain moment in time, I have my energy here. That is a normal signal. Then it flatlines, and then you see that Timeseer actually flags this issue in our application as well. So that's really quickly on how you can use it. Here you see a multivariate analysis, so we can do more complex analysis as well. I can quickly show you one. If I go into one of those events, for example, then you will see this is energy data that is correlated with flow data on a pump, for example. So So the below one is flow data, the top one is the energy data. And you see that energy profile having that spiky behavior, which breaks the correlation or the normal relation it should have with the flow. And then I can come in and say, okay, this is not correct. My energy measurement was doing strange things at that moment in time. And then I can say, I want to clean this. And then I want to remove, for example, the values in there, but I can use AI augmentation as well. And what it does then, for example, is now you see the new data that is being imputed here is actually based on the other signal or the flow, because the flow is still reliable. We can use that one to actually correct or impute data in my other signal. And that's really how Timeseer can work. You will see that in my analysis in here, then we also keep track of all repairs that have happened. And then you will see we have a full audit trail as well on everything that we corrected in here as well. So that's really quickly on how our application can be used. Let me quickly switch back to the slides. And then we can show the last part. Put it front and center. Right. Good. So you have seen it really exists. Then the last question is, of course, how do we make Nord really Nord for our customers? So I have a couple of examples from our customers as well on how they are using Timeseer or what are the specific applications they are using it for. One of those is a company, more than 100 production locations. It's a manufacturing company, and they were all actually rolling out energy dashboards across all those locations. But it was really slowed down because of the IoT energy meters they were deploying, because they wanted to monitor energy on a more granular level as well, were often unreliable. And especially you saw they built the dashboards, but then the second point on the slide here, no user adoption. Yeah, nobody adopted the dashboards because often there were issues in there that were actually not reflecting the reality because of data quality problems in there as well. And then you see the company we work with has a target of 0.5% company-wide energy reduction. That was really at risk because actually nobody was using the dashboards because of the bad or unreliable data in there, which we changed by putting Timeseer in between. And then actually within the flow, so we take the data, I didn't show it in the demo, but we have capabilities as well of automatically cleaning and correcting data. And in here we automatically correct data before it's being surfaced into the dashboards, or the opposite way around. If it's really too bad, the data, then we just keep it from surfacing towards the end users in the production plants as well, and we just put a notification on the dashboard that the data is unreliable in there. So that's one of the cases really at scale where our technology is being used to generate trust in the energy data that is actually being used. Another case that we did, it's not only on energy, but it's broader, so it's really on feedstock. So it's with a chemical company we're working with. And of course, there are a lot of utilities and feedstock flows that feed into the production. It's electricity, gas, steam, water, whatever it might be. But there is billing and invoicing, of course, with chemical plants are often integrated plants where utilities are then delivering towards the production locations as well. And there is billing and invoicing in between those parties as well. And often you have two measurements on the two sides, and based on those measurements, the billing is being done. The analysis that we actually did has shown that often there are deviations within those measurements, measuring the flow actually of the utilities towards the chemical customer we are working with, compared to the actual consumption. And then we actually noticed by analyzing the last year of data that 3 to 5% of the overall billed or invoiced amount is actually at risk because of unreliable data. Yeah, you can think about a chemical company, 3 to 5% of the billed or invoiced amount on all the utilities and the feedstock they are using. This is a significant amount as well. Similar to other cases, what we do now within the Timeseer application is we verify and validate the data proactively, that actually the procurement department of the chemical company can use trusted data before it's actually being used for billing and invoicing as well. Plus, it also gives auditability, traceability towards the providers of the feedstock and also their customers, of course, that the data they are using to do billing is reliable and is trusted and validated as well. The last example I have is more from a utility company that is Vitens in the Netherlands. Yeah, they, for example, monitor energy specifically on pumping stations. Yeah, as you can imagine, for water utility companies, the pumps within the distribution network are consuming a lot of energy, and it's one of the major costs for a water utility as well. So they do a lot of optimization processes on top of it. One of them being building a digital twin of the distribution network to be able to lower the pressure, for example, and to reduce energy consumption. But of course, to do so, they need reliable and trustworthy data. So that's what we enable with Timeseer. And on top of that, energy also needs to be reported towards government, together with groundwater levels, extraction from the ground, and so on. Energy is one stream that needs to be validated and reported towards government there as well. So there they also use our application to validate the data before it's being used in governmental reporting, actually. To wrap up, so yeah, in short, I think it's clear why it's important to validate specifically energy data. So we strongly believe from our point of view that the future of sensor data is clean, trusted, and actionable. That can actually be used to drive ESG compliance, more strict regulations, accurate billing, operational improvements, because everywhere you need that trusted data as well. Of course, it's not only about technology, it's a synergy of people, processes, and technology. We, from a Timeseer point of view, bring the technology, but that's also the reason why we partner up with Swan Black on this. And like Mike mentioned in the introduction, then we can really provide the entire package towards our joint customers. Both bring the technology, but also make sure that our technology is embedded in daily processes, embedded with people, that it also drives and delivers the value at scale. And of course, you want to scale fast, but typically we say to our customers as well, yeah, start small, start with a high value use case. I always talk about working value backwards. So start with a high value use case and start validating the data before it goes into that high value use case, instead of a very big bang approach and just throwing all your data into a sensor data validation flow like we do, because yeah, that will not bring the results you actually want to see. So start small, high value case. When you show the value there, scale it fast, similar to the example that I showed of the manufacturing company that now uses Timeseer across more than 100 plants as well to validate data. Yeah, to really wrap up, in here is, yeah, in a volatile energy world, data is your only control. So I think it's clear that this is key. And like mentioned, as sustainability requirements become more stringent and transparency expectations also increase, the cost of getting it wrong, having poor data quality will only rise over time. So I strongly believe that organizations that act now will not only de-risk compliance, but also accelerate efficiency gains and digital transformations initiatives you want you want to do on top of that data. So with that wraps up my presentation for now. And then I guess, Leah, we can open it up for questions if there are any.
Well, if the audience doesn't have any, one of the things that typically comes up is, how difficult is it to integrate automated data validation with a solution like Timeseer into an existing historian like Viva or Wonderware?
Yeah, we have connectivity. I didn't go too much into the technical details, but we have connectivity to all those systems. So yeah, integrating it with the existing technology or architecture that is already there is really fast. So yeah, we have customers that, of course, yeah, you need to handle a couple of the technical things, but where we went in a 2-hour meeting with the customer from connecting to the data, setting up the first case, configuring it, and having the same results in a 2-hour period as well. So it can really go fast.
Then you showed a couple of examples, but is there a typical place where you see companies starting in terms of wanting to improve energy data quality across multiple sites?
Yeah, we have in our application, we call it different quality gates or quality layers, if you can call it like that, for certain protection. The first one is what we call the data quality fundamentals. These are more really the fundamental things like, is there data still coming in? I have recent data. There are no flat lines in the data, no gaps. These kind of fundamental things. The second layer we put on top of it is more related to which type of measurement or sensor it is, because typically on different types of sensors you're going to do different types of validations as well. And the third layer of adding more advanced validation is related to where the data is being used. Because if you use it for billing, for example, yeah, you're typically going to be more sensitive in terms of identifying certain issues compared to when you use it for KPI reporting and generating a weekly KPI, for example, in there as well. And that's typically also how we build it up in those different layers. First, make sure you get the low-hanging fruit with not a lot of effort, get already a lot of the benefits, and then start adding more complexity as you go. It's actually nothing else than a continuous improvement cycle that you run through.
And I have one last one if the audience doesn't have any. But as Swan Black being the services partner with Timeseer, what does a typical implementation look like in terms of timeline, resources involved, that kind of thing?
Yeah, typically how we work is that there are different steps in there as well. Typically, the first thing that we do together with our customers is what we call an operational pilot. So where we actually run on one of the high-value cases, like I mentioned, in a subset, not the 100 plants I was talking about, but take 1 or 2 plants to actually get a kind of lighthouse case up and running to show the art of the possible actually and the benefits that it brings. That's typically first step. We can run very quickly those operational pilots. Typically, you have to go from 3 months, something like that, but it can go faster as well, depending on the specific case at hand. And during that pilot, we typically also define, together with the Swan Black team, define which are relevant cases to scale up after the initial pilot or get implemented after the initial pilot. And then we really go into a scaling and rollout mode. And that, of course, takes longer, depending on the exact scope of the cases that we scale.
And then last question, but beyond energy data, what are the other common use cases for automated data validation?
Yeah, it always comes back to those three buckets that I mentioned. People working manually with data. It's often not only energy data, but all types of things. Yeah, think about how many people today are massaging or analyzing data in Excel. I always call it the hell of Excel. But everybody has 10 different Excel files where they're analyzing all kinds of sensor data. So a lot of people, engineers, data scientists, business analysts are currently already manually validating data, but not in appropriate tools or like it should be. So there, everything is relevant. Yeah, on the more the enterprise cases where you continuously start predicting, for example, based on more advanced analytics. Yeah, think about everything with digital twins. Think about predictive maintenance. Think about process optimization. And then, of course, yeah, it becomes way broader than only the energy measurements that are relevant. And then for the third bucket, really on the reliability of sensors, yeah, it can be any sensor as long, of course, that the sensor is being used in a business process, because otherwise, yeah, it also doesn't make sense to start monitoring or automatically validating it if, yeah, it doesn't have an impact on whatever the application might be afterwards as well.
Great. That's all the questions that I had. Leah, were there any others in the chat?
Nope, that was all that came through. So thank you very much, Adrian and Mike, everybody for joining us today. Just a reminder, there will be a recording coming out. So watch for that, as well as a link to a survey for some feedback on the session. And yeah, have a great rest of the day.
Thanks, everyone.
Thank you all. Bye-bye.